Okay, so connected particles question 4b, which turns out to be the easier of the questions here. So it is 3 pulleys. So you have your pulley system here, and it's just like your standard, as I was saying, like your standard pulley system where you have the free weights. This is the kind of the standard question you're asked, where you have a free weight at either end, and then you have your movable pulley in the end, where the acceleration of that movable pulley is the average of the acceleration of the other free moving ones. And that's kind of got to do with, if that pulls down 1 meter there, and if that pulls down a certain amount length here as well, it'll mean some of this string will be removed, and it'll be the average of the up and downs of the side. Basically, it's kind of because you've just one string, and these have your standard tension always going away from the body, and the movable pulley in the middle has a tension on each string there. So the difference here is that you have this guy on a rough kind of plane here, like a wedge, although it's not moving, this wedge. So you have 2 mg, you resolve that to get your R value there, which turns out to be mg√3. You can then get your friction force, which is that R multiplied by mu, and that gives you a friction force of mg/7. So then for C, your force or tension is always moving away from the body. So you have and we know it's going this way, so that's your positive direction for this guy. So it's T minus your mg/7, the friction force, and then minus this component here, which is moving that direction here, which turns out to be 2mg/2, so it's mg. And all of that is equal to the mass, 2m, multiplied by the acceleration of that, which is a. So your mid one is 3mg, tension always acts away, and you have 2 of them here, minus 2t is equal to the 3m, and then of course this average acceleration of either side. This one is quite simple. It's your standard T minus mg equals mb. Okay, so with these ones, you're asked for, first of all, you're asked for separate diagrams, looking for the forces on the thing, and that's very important to do. So, and make sure you do those out with a nice big diagram. So you would draw this with your rough surface, and so make sure all your forces are in there. So FR, your force mg, your reactive force R, and your tension force, and do that for each body. And that's very easy marks for these questions, so make sure that you take the time to do those with nice big diagrams and nice and clear. So that's the easy bit. And then find in terms of the tension on the string. Well, looking at that then,